So, as promised, I'm going to show you all how to make quantum dots, and I'm going to be making cadmium selenide quantum dots. First, let me put some PPE on.
Hey, so this is post-production Craig, and I just wanted to say that if you like this video, please like it, share it, and repost it.
We're going to be dealing with heavy metal salts and high temperatures, so it's important that we protect ourselves from the reaction. I've gone ahead and grabbed all the chemicals I need, and I'll put a shot of those right here. Also gonna put some of these test tubes in here because I'm gonna need these later.
First, I'm weighing out the selenium. I'm tearing the scale to subtract the mass of the wave-out from the scale. I only needed like 30 milligrams, but I ended up weighing out like 43, so I ended up adjusting everything else to account for that extra bit of selenium. Selenium's like a fine black powder. Here, I'm making the reactive selenium precursor. I remembered I had some from a previous run, and so I'm just making some more and just adding it to that vial. I'm adding 1 octadecene, and then I'm going to add the selenium powder. I needed like 5 mils, so I'm just measuring that out here. But then I add trioctylphosphine, and that forms the reactive selenium compound, trioctylphosphine selenide. It doesn't really dissolve well. You either have to heat it or put it in the sonicator, which is what I opted to do. So after adding the trioctylphosphine, I just set it aside in there for 20 minutes while I did other things. The trioctylphosphine is in a septum sealed vial, so I needed a needle and syringe. I should have went with a larger diameter needle because this stuff is kind of viscous and it took forever to get out of the vial. Just gonna speed this up so you're not waiting here forever with me while I was doing this. Also, a bit about needle safety. Never recap needles unless you absolutely have to. So yeah, here I'm just adding the trioctylphosphine to the vial to make the trioctylphosphine selenide, and then I'm gonna put this in the sonicator for like 20 minutes while I prepare the other stuff for the reaction. Here I'm just setting up the flask for the reaction, and I'm gonna put a oil bath under this filled with silicone oil. Next, I am weighing out the cadmium oxide. It's a bright red powder. I needed like 13 milligrams of it for this. And side note about cadmium compounds, they're not only toxic, they're also carcinogenic. So yeah, definitely don't want to inhale or, ingest any of this stuff. But yeah, it's a bright red powder. Next, I'm going to add 1 octadecene, like 10 mils of it, and this is going to be the solvent for the reaction. And then I'm going to add a little bit of oleic acid, a couple mils, just to dissolve the cadmium oxide that I weighed out previously. This is going to form cadmium oleate, and the solution will go from red, because of the suspended cadmium oxide, to clear once it forms the oleate. Once everything was in there, I then lowered it into the oil bath and let it heat and stir until all the calcium oxide was dissolved in solution. Here I'm adding the oleic acid, but nice arms in the shot. So yeah, but yeah, just trust me that I added the oleic acid in there. And once everything was dissolved, then I could start the reaction. And you started the reaction by adding the selenium precursor. So here I'm just taking a pipette and getting 1 mil of it and then directly injecting it into the flask. Once I do this, this is where the reaction to make the cadmium selenide quantum dots starts, and almost immediately you can start to see a color change happen. And so from this point on now, I'm on a timer. I have to collect fractions from the reaction to get different size quantum dots. And the reaction goes from like a pale yellow to a yellow orange to red afterwards. But yeah, after this I'm just going to speed it up because I'm basically just doing the same thing, collecting different fractions to capture different size quantum dots in those tubes that I picked out earlier. These quantum dots won't be the best quality because they're exposed to oxygen. Normally you would do this under a nitrogen atmosphere. The oxygen creates surface traps, which minimizes the brightness of the nanocrystals. But yeah, I'm just going to shut up now so you can watch the reaction. And here are the different samples I collected. You can see the color darkens over time, and this indicates the growth of the nanocrystals, and you can see a UV image as well. And here's just a larger vial of the last time point ones. You can see that they're glowing very brightly. What I'm doing next is I'm taking a UV-vis spectroscopy measurement. So I'm taking a sample and I'm putting it in a glass container called a cuvette, and this just allows the light to pass through so that the spectrometer can measure it. And I just used all the sample just to make sure that the full light path was filled with the sample. And this is the spectrometer. The sample goes in that first little like square slot right there, and the light passes through it. And this is the readout from the spectrometer. It's sweeping a grating across the different wavelengths of light, and it's measuring at what point your sample is absorbing that light. And this peak right here is the band edge of this sample. So this is telling me the band gap between the valence and conduction band of this sample. And quantum dots also have a really characteristic absorption tail, which you'll see in about a second here. And yep, there it is. And this is just the absorbance spectrum of these quantum dots. If you like this video, be sure to give it a like and a share. And if you don't follow me already, please do so. This is Mad Bioengineer signing off.